All right, here we go. We're ready. All right, Day, don't get too excited. Day's very excited. Okay. All right, I know. I'm telling you, he is. We simply refer to him as the machine. Okay. He is the physics machine. All right. The first one says here, number 3. It says a bullet with a mass of 4.87 times 10 to the negative 3 kilograms is loaded into a gun. The loaded gun has a mass of 0.84 kilograms. It's a very small gun, I think. Probably a handgun, I would imagine. The bullet is fired, causing the gun to recoil at a speed of 5.3 meters per second. What is the speed of the bullet? Now, your signs are going to become very important, correct? Yes? So, we could do this the long way or the short way, correct? Yes? You know that, shall we do it the long way or the short way? Just the short way? Do a quickie? Okay. You know that the total momentum change of the bullet is going to be the same as the gun. Correct? They're going to be the same. Yes? And you just have to make sure that your velocities match up. Correct? That's it. So we'll put the gun on the left and the bullet on the right. Doesn't matter really. Okay? So what did I say? I think I spoke backwards. We'll put the gun over here. Put the gun over here. Okay? So this is the gun, this is the bullet. Okay? They're going to be equal. Correct? They're going to be opposite, but don't get crazy. Okay? You just have to make sure that your signs work. All right, so the gun is going to be 0.84. You just got to make sure your unit labels are okay. This is kilograms, all right? Meters per second, and that's going to be meters per second. Okay, so my gun is 0.84, and my sign is going to be, well, it says recoil, so we'll say negative, okay? Because you're going to say, well, forward, shooting it forward. Okay. It just has to be opposite. All right, so that's going to be negative what? 5.3? And that's going to equal, the bullet, very small bullet, 4.87 times 10 to the negative 3 kilograms. And then VB, right? Right? So, we can get rid of the sign, can't we? Can we get rid of that sign? Yes. You can assign the signs later. I'll show you how easy that is. All right. So you agree that they're going to be equal in magnitude, correct? All right. So what is this product, that change in momentum, divided by that mass? What is it?
The empty gun recoils at 1.3.
Did it say it's empty?
Yes.
All right, so we have to make that change, right? So it's 0.84. So can you make that correction for me? 0.84. What does it say? It says a bullet with that mass is loaded into a gun. The loaded gun has a mass of 0.84. So what is 0.84 minus that? Can you do that quickly for me? That's loaded, right? We got to have that by itself. So what's 0.84 minus that? It's going to be very similar.
1.83513.
What is it?
1.83513.
I'm sorry, I can't.
1.835.
1.3. Yes.
1.835.
0.835. 1.
Oh, 0.835. Is that what you're saying?
Yes.
Yes? Thank you very much, Edward Gisling. Thank you. Appreciate that. Okay, so what is this change in momentum, the empty gun and its recoil, divided by this value? What is it? 908? Really? So the velocity of the bullet, 908.7?
Yes.
Is that right? And then you can assign all these, like if I said, what was the velocity of the gun, you could say positive or negative, I don't really care. But then if I said in the same problem, well, what's the velocity of the bullet, it would have to, whatever it is, it would have to be the opposite of this, correct? That would be the only caveat. Yes? So let's make this change here, and that's going to be, because it says gun, 0.835. That's a nice catch, thank you. Okay? Yes? All right, next. 2 carts with a mass of 2.3 kilograms and 0.8 kilograms respectively are held together by a compressed spring. When released, the 2.3, this one, cart moves to the left with a velocity of 3.1 meters per second. Okay? And then what is the velocity of the 0.8 cart? Right? The 0.8 kilogram cart. So again, same idea. You just have to make sure that if you're going to assign the positive and negative after the problem, if you want to just work with the magnitude and not the directions, that's okay, providing your original setup is correct. So I would say that cart is going to be that velocity, is that correct? Yes? So the first cart, we'll say the first and second, so it's going to be 2.3 times 3.1,
Yes.
right? And then this will be 0.8 times the velocity. And what do you get? V2 equals what? What's 2.3 times 3.1 divided by 0.8?
8.9.
What do you get?
8.9.
8.9, okay, we'll say 9 meters per second, okay? Now, just remember, if you want to say, well, that's negative, then you say that's positive, or vice versa. What's important is that they're opposite. Clear? Understood? Yeah. You can always interpret the physics after the problem to make everything fit. It's okay. Or you could set the problem up, the equation up, mathematically correct as well as physically correct. Doesn't matter. Understood? Personally, I like to correct the physics after the problem is over. But either way. All right? We're done?